Welcome to This Explainer. I am so thrilled you're here with us today. If you've ever looked at your favorite mobile app, or maybe a massive piece of business software, or even just a simple digital tool, and wondered how it magically sprang into existence, well, you are absolutely in the right place. Today, we're taking a structured, step-by-step journey to discover how software is actually built from scratch. We're going to strip away all the heavy jargon and look straight at the actual blueprints of reality.
You hear it all the time, right? Hey, I have this amazing idea, let's just make an app. But what does that actually mean? People talk about it like you just wave a magic wand, hack out a few lines of code over the weekend, and boom, you've got a global platform. Okay, let's dive into this, because the reality is that creating reliable, efficient software is a rigorous discipline. It's far from magic. Actually, scratch that. It's not magic at all. It's a highly organized engineering process.
To really ground this concept, think about building a house. You would never just buy a giant pile of bricks, dump them in an empty lot, and just kind of hope a mansion appears, right? No way. You start with blueprints. From there, you gather your materials, you pour a solid foundation, you build the framework, and finally, you do the finishing work before anyone can actually move in. Software development is exactly the same thing. You need a design, you need a foundation, and you need a strict sequence of work before you ever hit that launch button. Here's our exact blueprint for today's explainer. First, we'll demystify the SDLC. Second, the waterfall model explained. Third, waterfall pros and cons. Fourth, a case study on a library system. And finally, number 5, waterfall versus Agile.
All right, section 1, demystifying the SDLC, the framework of creation.
Let's put some formal terminology to that house building metaphor we just talked about. Basically, everything in professional software engineering revolves around the SDLC, or the software development lifecycle. By definition, it's the overarching process used for planning, creating, testing, and deploying software. Now, why does this matter to you? Well, because following this framework is literally the only way to ensure the software you're building is high quality, efficient, and actually reliable. It's this intricate balancing act where project managers are constantly juggling 4 key things: cost, time, scope, and quality. Think about it. If you want more features, it's going to cost more time or money. If you slash the budget, the quality or scope is probably going to drop. The SDLC is exactly how you manage that tricky balance. And this brilliantly illustrates the circular motion of the SDLC in the modern tech industry. From planning to analysis to design, implementation, testing, and maintenance, the cycle just feeds right back into itself. Software is rarely ever finished, Once it's out there in the wild being maintained, new user needs pop up, which prompts a brand new phase of planning. It is a continuous loop of improvement and iteration. As we break down the specifics of what happens as we push a project forward, imagine a giant funnel. Up at the top, we're dealing with the big, high-level ideas, estimating costs, identifying risks, and figuring out what the end users actually need. Then, as we move down through the layers into design and building, those abstract ideas become concrete code. Next, we hit testing for bugs, deploying to the live environment, and finally, long-term maintenance. Every single piece of software you use on your phone or computer has passed through a funnel, just like this. Let's jump into section 2, the waterfall model explained, the sequential blueprint.
Okay, so now that we understand the overall life cycle, let's look at the absolute most structured, traditional way to move through it. The absolutely crucial point to remember here is that in the waterfall method, the flow is strictly sequential. Notice how the stages step down from requirements to design to implementation, verification, and maintenance. Just like a real waterfall out in nature, gravity pulls the water down, right? It doesn't flow back up. In this methodology, each strict phase builds heavily on the complete 100% finish of the previous one. You literally do not start designing until every single requirement is totally locked in. These are the 5 sequential steps of the waterfall model. It's a completely unyielding, straightforward path: requirements analysis, system design, implementation, testing, and finally, maintenance. Let's break these steps down into early and late phases to really grasp what this looks like day to day. So the early phases of waterfall, they are all about exhaustive preparation. During requirements analysis and system design, your project expectations are essentially frozen in place. You sit down with the client, you record their detailed needs, you map out the software architecture, and you select the exact platforms you're going to use. It's exactly like pouring that concrete foundation for our house. Once it's set, trying to change it later is going to be incredibly expensive and, frankly, incredibly painful.
Then we move into the late phases, and this is where the heavy lifting actually happens: implementation and testing. This is where your developers sit down and translate that massive stack of rigid design documents into real functioning code. And once the developers are completely done, they hand the whole shebang over to the quality assurance team. Testers check for errors across individual units and the system as a whole. Only after everything passes does the system go live into production.
Moving right along to Section 3, Waterfall Pros and Cons. Let's inspect the methodology.
Look, no system is perfect, so let's objectively inspect where this rigid structure truly shines and where it tends to crack. On the strength side, Waterfall is brilliantly easy to understand. It provides clear structure, wonderfully defined milestones, and strict management control. You always know exactly where you are on the timeline. But, interestingly enough, those exact same strengths create its biggest deficiencies. Because your deliverables are frozen, it severely inhibits flexibility. All the integration happens in one massive big bang at the very end. And the most dangerous part? The customer rarely gets to preview the system until the testing phase, which means if the initial requirements were even slightly misunderstood, it might be way too late to fix them without massive cost overruns. So knowing those constraints, when should you actually pull the waterfall model out of your toolbox? Basically, you deploy it in low-risk scenarios. It's for when the product definition is highly stable, the requirements are completely known upfront, and the technology is deeply familiar to your team. Think of things like porting existing software to a new platform or building systems where quality and safety are drastically more important than a fast schedule. Stuff like medical device software or aerospace systems. You definitely don't want to rush those. All right, Section 4, Case Study on a Library System. Let's apply this theory. Let's pivot from all this abstract theory and see how this works in practice. We're going to look at Cambridge University. Their background was a classic, frustrating, operational headache. They had this entirely manual library management system. Book borrowing and returning were recorded by hand in physical registers. As you can probably guess, this was highly inefficient. It led to frequent errors, lost books, messy records, and massive delays just trying to figure out who had overdue materials. They desperately needed an automated system to streamline everything. So what did they do? They laid out their requirements crystal clear. The new system absolutely had to allow students to search for books and check availability. It had to let users borrow and return books digitally, and it had to give librarians the tools to track overdue inventory and calculate fines. Notice something about these rules. They are incredibly stable. A library's core function doesn't change every 3 weeks. And because these rules were fixed and predictable right from the start, the university wisely chose the structured waterfall model to build it. For this specific job, it was absolutely the perfect tool. Which brings us to our final section, Section 5, Waterfall versus Agile, the evolution of work. So that library system was a great fit for Waterfall, but what happens when the requirements do change? Now, what's really interesting about this slide is the contrast in how these two methodologies actually feel to work in. On one hand, you have the waterfall process. It's like a single, massive, heavy project block being dragged across the finish line. It's a huge burden, and you just kind of hope you can deliver it all at once. On the other hand, there's Agile. The project is broken down into flexible, bite-sized puzzle sections. It's lighter, it's way more manageable, and you get the satisfaction of delivering actual value continuously. You can immediately see why Agile was created. While Waterfall steps down rigidly and never goes backward, Agile is a continuous loop of sprints. In Agile, you take a small piece of the project, you design, develop, test, and deploy just that piece. Then you review it with the client, get their feedback, and start the cycle over for the next piece. It perfectly reflects the true problem-solving nature of modern software development, because, let's be honest, sometimes you really don't know the full solution until you actually start building it. Let's lock this understanding in with a quick definitive summary. The approach for Waterfall is sequential. For Agile, it's iterative. Flexibility in Waterfall, very rigid. Agile, highly flexible. In Waterfall, testing only happens at the very end, after implementation is totally done, whereas Agile demands continuous testing throughout every single sprint. Finally, client involvement in Waterfall is pretty minimal after the initial planning phase, but in Agile, the client is highly involved, reviewing the work constantly throughout the entire development process. All right, so here is the final verdict, the ultimate rule of thumb you should carry with you. Neither methodology is inherently bad. It entirely depends on the stability of your project definition. Use Waterfall when you have fixed, unchanging requirements and a crystal clear end goal. But use Agile for dynamic, evolving projects where requirements are highly likely to change as the market shifts or as user needs become clearer. So, as we wrap up this explainer, I want to leave you with a question to really ponder for your own work.
Think about the next big endeavor you're planning. Will your next project require the strict, unyielding blueprint of the waterfall methodology, or is it going to demand the highly adaptable, bite-sized, flexible puzzle of Agile? The success of your creation entirely depends on choosing the right framework from day one.